those were outstanding presentations right through, and I really like the mix. I like the diversity of topics and approaches, and then how they come together. I have a few comments I want to direct to Stuart, so I'll wait till he gets back on. But my sense, I've got several pages of scribbles here for interesting points that I thought might be points of connection. But rather than me as a moderator jumping in and framing everything, let me just open it up right off the bat for some conversations back and forth on some of the different issues that you raised. There were questions that we probably could have kept going on with Deb's presentation and groundwater issues. We could probably talk all day about the exciting UV work. Chandra, I'm really excited about where you're going with a lot of this computing work. That is just amazing. Olivier's keeps moving. You're a moving target, Olivier, because I think of you as the guy trying to figure out the data on water use using the energy and all that, and you've moved well beyond that. So it's hard to catch up and keep up with you. So why don't you guys just start with anything you've got between you, and that may well take the 45 minutes that we have allocated. If not, I have plenty of ways to goose this thing along. Floor is open. Why don't you take your mics off so we can just go back and forth? And who wants to jump in?
One of the things that Olivier mentioned that I'd like to raise again, hopefully Stuart is back. I see his name. Is the Sigma regulations that are coming down, and maybe you could say a few words of what's going to happen and kind of give us more detail on how that's going to change things. I think it's useful for us to all think about.
Just as a moderator, because I remember the old, God, what was it? McNeil Air Show, where they always would help you with the acronyms. So Sigma is the Sustainable Groundwater Management Act, which was passed in California in 2014. In an effort to help us get a grip on groundwater overdraft and moving back to some kind of a sustainable management regime for groundwater, which obviously has surface water implications because they're linked. So just to frame that question. Olivier, you want to jump in on that one?
Sure. We've entered a monitoring phase since January. Will last until 2025 for the priority basin. And I think the work you're doing and some analytics I'm doing, and I think understanding the dynamicity of a farming system, you have dry year, wet years, is where the state is. And I think that the fact the energy, water, and food sectors work in silos is where we're gonna, this type of events will allow us to redesign the entire system. And so on the ground, there's 3 or 4 reactions. Some people will look at groundwater recharge. If you're in a white area, white being district to deliver surface water, some people will look at buying land to follow the ground and claim the water rights near Kern County when it's overdrafted already. I think one of the big opportunities that I saw today is if you look at the food and ag sector as a vertical sector that has great data, great technology, and people like Stuart will deliver a finished product, you have a little bit more latitude to move your revenue base and maintain jobs, because your technology is going to disrupt something. You might use less water here, but you may have local jobs, doing some solar asset management, and still produce the same amount of proteins or food for the state of California. So we have to look at kind of that economic base, and that's why I gave the example of Brittany has been extremely successful by leveraging its nexus of seafood processing and farming, and the equivalent of we didn't have the water issue, but nitrate management was the equivalent of Sigma, and it was very, very divisive. And I think the conversation we can have to help the farming industry is to help keep that economic base and reinvest across those 3 sectors, so we can use that water for the right impact through energy intensive functions or growing food, indoor, outdoor. So that's the exciting thing. But short term, a farm, as a title, And I think Stuart hit on some very important limitations. You know, if you have a piece of land and you have a water right, and groundwater is not beneficial use, you're screwed. If you can't put solar for 30 years and do a lease without losing your water right, you're screwed. And so, you know, there's not enough flexibility in the system for the growers to have the opportunities that other industries have. And I think that's where, you know, they need a little bit of support, not only in innovation technologically, but also in policy making. And I think, again, if we look at what we saw today, the ability to have innovation coming in food processing, farming, the amount of water can be reduced without economic impact. But we got to think differently. I think today is a great opportunity to kind of bridge those silos.
Stuart, are you back with us? I see your name there.
I am.
Oh, great. Okay, good. That's the important thing because we're just going to go in an open conversation here for the balance of the time before we do a closing. So the question, if you caught that, was about Sigma and how does that play into some of these issues. Deb, do you want to comment on that as well? You're all about depth to groundwater and what is there, which is really what's the ultimate question for Sigma is how to manage back up to a level that's sustainable. And the obvious implication from your work is that there are significant energy saving opportunities in replenishing the groundwater because less depth to groundwater, less pumping energy. So if you can hold it at a higher level, you actually get energy benefits as well as water benefits. You want to comment on that?
Yes, thank you. So the way that I think about Sigma, and I think the way that a lot of people think about Sigma, is that you could increase supply, decrease demand, or do a combination of both. And like Stuart said, recharge is going to be fundamental for moving Sigma forward. What we also know is that during drought times, we may not have the water to do recharge. And so we also have to think about what opportunities are there for reducing the demand without really impacting farmers, households, industries more generally. And so some of the work that I'm doing connected to the work that you saw today was looking at what are other Western states doing? What sort of policy mechanisms are they using? What strategies are they using? And what strategies are working to reduce that impact on declining water levels? And I don't really have an answer today. And the reason for that is because we've been asking this question for the past 6 years. And because the Western states all manage groundwater very differently, we're sort of just at the point where we've collected all the different places that have sort of managed groundwater differently. And I think that really is going to give us just a large sample, big data for law, to see, you know, all these different ways people are using mechanisms to decrease withdrawals, to come up with ones that really work and don't put large burdens on folks that are currently using groundwater.
Bob, I want to add something.
Please.
Just so when we think about this internally, you know, I always go down and look at all the crops that are grown in California. And let's just say we have about 8.5 million irrigated acres in California. And you go down the list of, like, you know, the low value commodities, whether it's alfalfa, cotton, grain, barley, you know, you just go down this list and we look at that and we think, certainly if we're competing for water and the cost of water is going up, we look at those crops getting squeezed a lot harder than almonds, pistachios, wine grapes, citrus, and what have you. And this is why we think there's consolidation coming, and there's going to be even greater pressure on, like, the dairies because they utilize a lot of those crops. So it's crazy at a time where you would think you want less hard demand in the state for limited water. I think we're going to harden it further with more permanent crops.
I think that's a really important point. As you move up that value chain, you are looking at a lot of hardening, but we're also exporting even raw alfalfa to the Middle East, to China, and so forth. So we've got some interesting, I think your point is very valid, very interesting dynamics in the markets that make certain things seem reasonable at a certain period of time, may change. I'm really intrigued with your move to solar and taking land that you're taking out of production and farming energy instead of food as part of your portfolio and shifting that direction. I like you throwing up the picture of the pickup truck, because I think Stuart and I were talking briefly about on-farm equipment going electric. You're seeing an awful lot of all the stuff we use at home, from a drill to a weed whip, everything's going on a battery. And vehicles are rapidly going this direction and so forth. But I've seen very little about equipment, like on-farm equipment. Semis are going toward electric, and GM just released and sold out their new Hummer in a day. If you want to put $100 down, you can get your 100 back. So I guess that's not that significant, but they sold out their whole run for next year in a day. So there's clearly a move in this direction, and it has huge implications if you can farm your own energy, set up your own microgrids or mini grids or whatever grid arrangement, and kind of work off your own assets rather than bringing fossil fuels in. That's pretty dramatic stuff. Are other people thinking the way you're thinking, Stuart, or are you way ahead of the pack there?
No, I'm pretty much just a visionary. No, of course they are. I mean, no,
you're a significant grower. If the other big ones are thinking that way, that could be a big shift in ag in a very short time.
Bob, honestly, this is a thing right now that's really, so I'm in the Westlands Water District. It's a 600,000 acre district. And we're right now working at a district level to convince our board there that we should be encouraging growers to put in solar. We think this is the future, and it's not much of an incentive if you lose your water rights if you put a solar project on. And we right now are getting a lot of pushback that whatever water was associated with that land, because it's not an agricultural use, should go to every other landowner in the district. And we're struggling with this right now. And it just occurs to me that most of those board members must not be thinking about this, not to say we're right, but we just think we're going to have fallow land. Why aren't we generating income off of it with a non-irrigable use? And we think solar is a sound way to go. So I think others are thinking about it, but I'm just surprised that there isn't more policy and more push to have the right policies in place to make it happen.
Could you talk a little bit about the size of the project you mentioned? Because the net metering allows farmers to do their own solar project up to 1 megawatt to offset the energy use of pumping. But in the case you're leasing a larger area, could you mention the size of the project? Is it utility scale or something else?
Yeah, it's a utility scale project. So it's 1,600 acres. I think it's like 225 megawatts with a capacity battery storage of about for 100 megs. I mean, it's a pretty good sized project. My argument to my friends in the district is, look, if a guy puts out like 5 acres for a single megawatt system to run his wells, you shouldn't take his water away on those 5 acres. It's really not that much of a different argument if you have 1,600 acres. And don't we want to encourage investment and income coming through the district? I continue to pay all land-based charges and fees on the lands that we have within this water district. I think we should all be, and I think, Olivier, there's going to be more and more growers putting in solar systems for their wells. So,
right.
Yeah.
That's a big finding we found from our satellite-based imagery. Bob, you were talking about how we're moving it. It's really around tracking water. We found that there's no one way to track water. We've done a really good job measuring at the pump. But if you're a grower looking at water use efficiency, you have to know where it's going. And that's a surprisingly complicated process. And so we look at satellite imagery, and we found some interesting clusters on the east side, but what we found is exactly what Stuart said on the west side, that this crop rotation is going to be replaced by some anchors, in terms of crops that can pay for deeper wells. And so we got to look at a system level if we're going to do some groundwater recharge, because water is better to store. Then what about solar, which is better at continuously generating income? So if we look at the physical properties of electrons, they're great to transmit on the grid. Water molecules are great and cheap to store. So if you look at those fundamental attributes, you can redesign a wetland district in a way it's economically viable. And I think what you're saying, Stuart, is very important. And so we saw that from the imagery. When we converted that water demand map into energy heat map, it became very obvious. And it's interesting to see, Stuart, that whether it's a small farm or large farm, the penetration in your area is double the penetration of solar project in the rest of the Central Valley.
I would add, I want to add one other thing. So we have a deposit. I told Bob this on a Rivian, the new electric truck that's coming out. And what I think is kind of noteworthy, we placed that deposit about a year ago. And I told my farm managers, one of you guys is going to be driving an electric truck. And they all poo-pooed that idea. But since then, I've had a number of them say, hey, I'll be the guy. I'll drive it. I mean, they're totally like coming around. So it's coming, right?
It's a pretty impressive, at least from their literature, it's a pretty impressive thing. Let me shift a little bit to, Steve was showing us some vertical farming in buildings, and Chandra's talking about this CUPS model, which is, a version of a building, a building of net, basically. But are we headed to a situation where we're going to be able to control the environment and use less pesticides and so forth, and recycle the water on that 1 to 5% and so forth? That's a very intriguing model, at least for certain crops in certain areas. What's the sense of where we're headed with that kind of innovation and food production?
Maybe just let me comment on the LED lighting. The biggest implementers have been the Netherlands. The Netherlands are the #2 food producer in the world, and it's mainly they've used it. They're the first ones to really implement LED lighting at night. But like I said, it's for very high value crops, like the tulips industry, believe it or not. Mm-hmm. And some of the food, some tomatoes are grown horticulture. Is done at night as well. And actually, I had a question for Stuart, because I understood that they come up with a light recipe to tailor the taste of the tomato. And my question for Stuart is, what controls the sugar content in your tomato? Do you know the effect of light on that at all?
Here's what I do know is I was in Brazil looking at tomato production there, and they made the comment that, their season is actually, they're growing these tomatoes in the winter because it just gets too hot and what have you during their summers. And I was told their challenge is they get fewer solids because they have fewer light hours.
Okay.
Yeah. So that's about the extent of my knowledge.
Yeah, when you fly over Holland, it's amazing. It looks like an LED color field down there. But they're the only ones really to go after it in a big way. I have seen some of the, I hate to say this, some of the farms south of Santa Barbara. I think it's Carpinteria is one of the largest growers of cannabis. They're growing that around the clock, so they're using some LED lighting there as well. But I wonder if there's a hybrid model where you don't have to build these huge greenhouses, and that's why we wanted to work with Chandra and see what we could do, to help with the pesticide problem, which was develop UV light there to attract the pests, and/or LED lights to help with her kind of implementations. You have any comments there, Chandra?
Yeah, so I would just say in general, any type of structure based farming is, I think real far out. I do see it. I have a lot of, it's come to the fore because of the cannabis industry. A lot of the technology and the railings and the robotics and the lighting that we have available to us today, and how low cost it is, has become because of that industry that has come up. So I just wanted to say I've seen that as well. But I get a lot of pushback on any type of structure-based farming because it's just such a huge cost. And the margins are just, like Stuart was saying, just so slim, except for very high value crops, like you said, Steve. So I see that as well. I do think it's important to study it because it's possible that we'll have to get there with pests and diseases that are going to become more and more common as we move into the future. So I think it's important to see how far we can go with it. And maybe for some high value crops, it's going to be vital. I also think there's some interesting things that Steve and I had talked about. I just wanted to share is attracting pests, repelling pests. I think lighting is going to be something that's going to be very interesting to use, not even in structures, just outdoors. I also have colleagues who are very interested in using it to guide growth, to actually encourage growth in a certain way that makes harvesting mechanically more and automatically more efficient. So, we grow wine grapes on vines. They walk the vines up in a particular way to produce the food, the grape better, but also in citrus, it's really expensive to harvest. And could we do something better if we were able to encourage growth in certain ways? So I think that those are going to be interesting aspects, but again, I think that's really far out. So I'd like to go back to maybe Stuart to comment on, his view of some of these more advanced ideas of, growing indoors. And, are you just, do you even see that in your lifetime or your son's lifetime, perhaps with the tomatoes or with the nuts?
Well, so, clearly like trees and what, I think that's a taller order, right?
Yeah,
and I think,
sure.
Steve, you said it. These systems for high value crops like, well, marijuana or whatever, cannabis, clearly I don't think it's going to go away, but I look at something like I was thinking about processing tomatoes, and could we have a huge kind of greenhouse where we're pumping maybe some of the CO2 coming out of our boilers back into facilities and what have you. But I sat back and I thought, right now, we think we have a good tomato price because we're getting paid $75 a ton. That's 3.5 cents a pound. Can we really grow something for less than 3.5 cents a pound? And, I don't know what the capital expense would be, but it's going to be huge, right, to try to do that indoors. So I don't know if it'll be in my son's lifetime, if ever. But I think things like romaine lettuce, where they have food safety issues just from the structure of the plant and how it captures water and whatever in there. I think there's definitely a place for vegetables and higher end, specialty crops.
I agree, Stuart. And what's interesting when you look at the energy footprint of transportation and the safety issues, those fresh produce are perishable. And so moving them around with pretty large food waste is not the most efficient to do it, because you can probably grow that in some containers like Plenty does. But that's only, very niche part of the production. There are other produce that you can process, and a processor like yours can be very efficient because it's like your hybrid networking model, Chandra. If you're processing the crop locally, you can store it, which gives you a lot of different options. And then there are some crops like almond. If you process it even locally, you still have to grow it, and the intensity of the energy means that energy wise you can't grow it at a cost function. So I think we have a portfolio of approaches if we think about a system design for California to be very efficient. but the policy has to be there to let some urban players to take some industrial buildings like in San Francisco and turn them over into local fresh produce farms. Similarly, you can have people in the wetland district that's built around water to become a player in solar. So we're going to have to kind of break the mold a little bit and play to kind of reinvent the farming of the future.
Steve, your comment on the Dutch model was interesting for me. About 10 years ago, I was down in Ethiopia for a Nile Basin water deal. And I'm driving out through a very arid area after miles and miles of brand new greenhouses, all artificially lit, irrigation in a very dry area. People are just getting by. And it's all for flowers. It was all for the European flower market. It's all Dutch companies that own and install. And it was interesting because on the one hand, it's very water efficient and it's creating a lot of jobs and so forth. On the other, there are people starving just down the road. So it really started to cause me to think about, the pluses and the minuses and the technology. But it is happening, and it's happening all over the world, not just in the developed countries.
Yeah, I understand. Australia actually has a startup where you actually buy the greenhouse with the LEDs in it and the water and the thing. It's like a modular home or something. But like I said, I think it was for cannabis growers. But as the cost comes down, and LED costs have really dropped to the point where it's cheaper than the high pressure sodium which was used. And one thing I didn't see implemented yet is you could basically power the thing with solar cells. So nobody's basically integrated the energy aspect. So you could just have solar cells to get ready for it to drive at night. It's kind of like your solar powered LED garden lights, right? It has a solar cell on top and then it comes on at night and you don't have to go on grid anymore. You just stick these things in your yard, and I replace them like every 5 years, and they've gotten brighter and brighter. So I think, that one's identified. What I haven't solved is the water piece. Like you said, I know you can recirculate it in the greenhouse, and I just wonder if there's some crops, definitely not agave, that Stuart could grow, that he could just buy one of these greenhouses and put it in. I know that like basil and some of these really expensive microgreens, I think it's cost effective enough that they're using it at Whole Foods, but they built their own one. They're using a semi tractor trailer, the you see behind the semis. They're just buying old ones. They're putting them in, so they don't even have any light that comes in. They put in LED lights in it and water, and that's what they're using to grow their microgreens. So I think there's some crops that we could probably start to look at, but like I said, nobody's really, besides the Dutch, come up with a pretty good model of what you can grow. I think it's just a cost benefit analysis. But like I said, it'd be nice to get the solar to be integrated in there, and then it's almost entirely off grid. The water pump, you can imagine it just recycles itself. The pumps and the lights are all driven with the solar cells. Would be pretty cool. And California Central Valley is ideal for that type of setup.
Hey, Stuart, are you going to need some research help on your tequila?
Yes, I need somebody to actually be tasting it to see if it's any good.
I was going to say, there could be a collaborative here. I'm sure DenBaars can figure out a way to put that together through the IEE.
You got to try, next time you come, Stuart, you got to try John's Limoncello.
Okay.
You can try it.
So Steve, I have a question for you. So in our almond processing plant, we're looking at, perhaps investing in a large scale pasteurizer with, its moisture, its heat, it's all this kind of stuff. But I mean, how far away are we from having a UV system that we could run, say, nuts through?
Wow, good question. So a UV LED one is still, I think, out of reach. However, a mercury lamp based one, which is literally just a fluorescent tube with the phosphor, the white stuff scraped off. I have seen those. They're being used for in wastewater treatment. Before they discharge wastewater, they're using the UV lamps. I would think that a UV lamp based one is to the point where it would be almost cost as efficient as the heat based one. Now I can do a little bit of research and see if anybody's made one for a food processing plant. I know the Mars Candy Bar Company was starting to look at it. It's just such a new area that people really haven't gone through the testing. But I would think that is not UV LEDs yet. You just buy a UV lamp based one, and you have it over your conveyor belt where you're using to sense the almonds, and you turn that on. That might work. And like I said, they make one for water-based systems, which is a ton of water going through those systems. But we should look and see if I can find one that's developed yet for food safety. I think you just got to be able to flip the nuts over. You need to hit them both sides with the. We need to like put it on a transparent plate and then have the UV on each side of it or something like that. I just don't know if anybody's built a system like that yet.
Thank you.
In principle, you should have to be able to get to the power densities. If they can do water, you should be able to do almonds for sure.
There's a fair amount of potable water treatment using that technology too.
Yeah. Yeah, and there they can't heat up the water. It's too expensive. So they're hitting it. First they hit it with chemicals, and then they do like some silver. And usually the UV is the last thing that they hit it with. And like you said, some of it's good enough that you could drink it.
Mm-hmm. Other comments, questions, ideas, potential for collaboration? That was a good one there.
There's a couple questions from Bruce on our Q&A. I think are interesting.
Please go ahead. I'm not reading that, so.
So the first one is for Stuart from his talk. You talk about use of GMO technologies to create better plants. The question is the GMO resistance movement and the labeling requirements that are coming about, is that causing a huge impact on those who are relying on GMOs for efficiencies?
Yes. Yeah, we have a number of customers that, will tout on their labels that it's non-GMO and what have you. It's funny. I hope I'm not breaching any confident with whatever, but I'm always struck that we produce a lot of tomatoes for Heinz. And if you look at a Heinz ketchup bottle, it says grown, not made, because they propagate their own seed. And yet, as far as I know, I think there's a lot of high fructose corn syrup in there from genetically modified corn. It's just kind of a crazy thing. And I believe a company like Heinz could actually really move the needle if we could come up with tomato varieties that are more drought tolerant, that will produce more sugars, all the things to address kind of the issues we have before us.
That's interesting. The other question in the Q&A is again for you, Stuart. We're trying to get scale, so people produce one crop in large amounts, but then the transport and getting it to the people who are actually going to consume it or process it costs money. One question is there any movement on having a piece of land where you're growing lots of different things, potentially full meal crops? Is that anything anybody's talking about, or is there any potential there?
Well, yeah, I guess, there are a lot of CSAs and what have you in all of our communities, but I think the thing about the food business and from a farmer's perspective, I think you've got small, local, more diverse, what have you. And then you have the companies that are basically supplying the major food manufacturers, right? So it's kind of a bifurcated market. So my customers are not, my neighbors here in Fresno. My customers are kind of all over the world. And so we're focused on crops where we think we have global competitive advantage. They can't grow almonds in the Midwest, and they can't, there's a lot of these things that are kind of unique to California. And I think we're going to continue to focus on the regions that hold competitive advantage. So we grow a lot of different crops, and we rotate, for example, our tomatoes with crops that we don't make any money on, but it's good for the rotation. And so we grow garlic, onions, grains, a little cotton. Before you think I'm just crazy growing cotton, we grow it in part because cotton is kind of a host crop for a lot of insects that we can treat in cotton that we can't in tomatoes.
Oh, it's fascinating. I had no idea. That was very, very interesting. Another question for you, Stuart, on the Q&A is talking about your agave plan. Yeah, that you shared your secret with us. Jordan asked, are you planning on growing blue agave for sweetener and tequila production, or some other variety like mezcal production? For either
Yes.
choice, what made you choose that type?
Well, think about it, you guys. I already have about 7,000 acres that I'm fallowing. With Sigma, I'm going to have more. And I was sitting around thinking, what could I grow that would be drought tolerant, that, I could utilize some of these lands that are available. And anyway, as I was sipping some tequila, I thought, why only in Mexico? We used to be part of Mexico. So anyway, I have about 25 different agave plants in a test plot right now. The majority are blue agave. And this could be the craziest idea ever, but I would tell you this. We put them on drip irrigation. We laid all these things out, have run all these tests. This is our first year. And one thing we found was we were putting very little water on them, but we were overwatering them, and which is like a dream come true, right? So we've cut the water, and now they've all perked up and they appear to be doing better. So I think we'll be doing probably 4 or 5 different varieties. Some of them are a little more drought tolerant than others. And I don't know, maybe it's the craziest idea ever, but I'm kind of excited about it.
Stuart, you mentioned that going to drip for some of your operations led to reducing passes in the field, so less traction, less diesel fuel. That's an interesting dimension of energy efficiency, keying one strategy with, in this case, water application to, you think of pumping and all that, but that diesel fuel is a significant piece, both from an energy standpoint and an emission standpoint. So that's exciting to me that you've got that kind of thing going. Do you get climate credit for any of that, for practices that reduce emissions like that?
Of course not. Of course we think we should, but a lot of these practices we've adopted over, the last 30, 40 years. But, you put a drip line in, and you plan on having it in the ground for 5, 6, 7 years, depending on, how thick the line is. But the minute it's in the ground, you quit running the big stubble disc to break down the beds at the end of the season. And you quit running the, building new beds and what have you. You try to maintain your bed, and you want that bed with the drip line right in the middle to, you don't want to shift it around. So I think we reduced our passes. We more than cut them in half from farming with furrow irrigated fields to drip. And we suspected that would happen. But not only did that happen, then the equipment got a lot better. And anyway, it's been a great improvement.
It's an interesting example for the energy efficiency thinking, the systems thinking here of how these things are connected. We've got a couple more minutes, I think, and then I'll hand it back over to Mark for the closing bit.
Hey, Stuart, I just posted in the chat a link to a UV food processor sterilizer that you might want to look at. It looks like they do fruits and vegetables.
Thank you. I appreciate that.
It looks like John has a question.
I had a question for all the panelists. Obviously, the problems we're all encountering are even worse in Africa. And I wondered if any of you were working on this sort of work that you talked about in Africa, and if not, sort of what's possible there, because I think they have, whether it's groundwater or enhanced farming or whatever, the needs are even greater. So
Deb, have you done groundwater work in Africa?
So I'm actually just starting a project there. I'm working with a new postdoc that Scott Giuseco and I are collaborating with, and we're doing some of the stuff that you're seeing, that you saw today in the United States, in Ethiopia to start out with, through a number of collaborations there, and a lot of opportunity there. Right now, a lot of rain-fed agriculture and opportunity to see if we can increase productivity through irrigated agriculture through groundwater. And the question is, how can we do that and inform that move to irrigation through lessons learned in places where we're actually depleting groundwater currently, so that we could sort of start out with a more systems view of what's happening. And so that's ongoing work that we're doing.
John, I think the basis of that, I think it's great because, we're talking about where can we really move the needle? We're probably going to be able to move it in California, but I think in other regions of the world where we can take these learnings, that's where we're going to have the greatest impact, I think, on global energy and food and all that kind of stuff. I'm really intrigued by that.
Good.
Yeah, I think that's a good point. I think from in my perspective, from the technology side, it's also interesting in that just the lack of electricity is a huge impediment, but also what a huge opportunity is there. We don't work on there in Africa directly, but I've had a lot of colleagues who do, and I think there's a lot of potential there. There's so much use of cell phones. Smartphones are ubiquitous. And these are small supercomputers, given what technology looked like 10 years ago. And so there's a lot of analytics and data collection. They call them data mules, where you can collect data as you're walking through the field or working on the field on your smartphones. It's kind of a leapfrog technology. They've jumped over all of the incremental kind of baby steps we've taken to have these applications that give them lots of actionable insights. It's more recommendation systems that I know about, but you can see how that might turn into automation, actuation, control that's data driven in the near future.
I'd like to rebound on the cellular phone aspect, Chandra, because when you think about the water energy nexus, it's everywhere. I mean, whether it's India was overdrafted basin to in Africa, it's very distributed. So if you look at 1 or 2 acre plots, it's a different scale, you can trickle down some information very efficiently. So the opportunity is, if you can buy a solar powered pump, a small pump kit, you can allow someone in a village to be more efficient. You can maybe look at very efficient LED lights, and suddenly you can do a number of sensitization function, and suddenly some of the women involved don't have to walk as far as they do now to get drinking water. So you can completely shift the equation with those small and distributed systems. I think it's a slightly different economics. You have a lot of work at the Bloom centers across the UC system, and MIT does a lot of that. It's the same equation. It's just you have to bring it down to smaller system. That's where some of the things they're doing are very useful. On our end, we would need to have very good data models based on a lot of data in California to be able to predict things that you currently need a sensor for. But let's imagine with satellite data and information about the soil, you could potentially help people do irrigation with just basic information by phone. That's kind of where we're going beyond California, and we're very interested to work with the UCSB. The interesting part is UC is already involved in those things through USAID program. A lot of the satellite imagery is already processed by a number of departments, like the Department of Geography, to track famine. So it's like microdata. So I think the tricky part is, like I've shown with our water algorithm, what can you do now that is useful to be able to engage conversations, identify the problem, because what Stuart said is probably going to be true when we go to Africa. A lot of good ideas, a lot of wannabe startups, but not all are going to make it. So if we can find some first use based on that historical connection that some of the UC labs have in the past, I don't think technology is the barrier. You can push that information very efficiently. What we found is the barrier is microfinancing if you look at most of those innovation. And so how do you get some small amount of capital to the stakeholders that can drive change? So I know the Institute have done very well with solar lighting to drive education up, and maybe John can talk about that. But if you imagine, a system like that, how do you get $10 or $20 to someone who can buy a piece of equipment that can change farming on a 1 or 2 acre plot? So that the move of money at a very granular size, I think is a difficulty. We know how to do big farming. We know how to do big financing. If you look, Plenty just raised $100 million, and Driscoll is involved because they control the strawberry market. I think financing to move the needle across thousands of 2 to 5 acre farms to be self-sustainable requires other kinds of innovation.